Right. That's actually, I've heard instructors,
Really?
yeah, I'll randomly trim it to the right size. You're like, no.
You took off absolute zero. I don't know what it is.
So we have a couple of topics in this chapter. And actually, one of the topics, the wind chill, very quite appropriate, right? Wind chill feels like temperature and heat index. Actually, those did make it to those are in your review sheet for chapter 3, so I made it to the test. But just to kind of remind you, we have 3 temperature scales. I don't know if you can see it at the top there. If you're like me, you definitely look at the Fahrenheit scale. These 2 over here, Celsius and Kelvin scale, that is more definitely where science goes. Okay, basically scientists across the world, those are metric. So when we get going, actually, the Celsius temperature scale is probably what we're going to kind of segue to. But anyway, some kind of notes there. Of course, water boils at 100 degrees Celsius, 212 Fahrenheit. Yep. It freezes at, as long as you don't add salt, right? It freezes the lower temperature if you add salt. Pure water freezes at 32 Fahrenheit, 0 Celsius. Room temperature is about 22 Celsius. And we looked at record temperatures earlier in this chapter, and so about 136 was the highest world temperature ever.
Is that the Death Valley one?
I can't remember. It might have been Libya or something. I don't know.
It was in here.
So.
I remember seeing it.
Okay. So this one is kind of fun, I think. So how many people set their heater on 65? How many people are 65? How many people warmer than 65? That's probably me.
We're like 7.
Well, how about in the summertime? How many people set it on 65 in summertime?
About 60.
Yeah. You set it warmer for 65 in summertime?
I said about 60.
Okay, in summertime. That's not bad. But what this does is basically say you're going to set your furnace on 65 and you're going to set your air conditioner on 65. And basically it adds up the degrees that are beyond that when your heater or your AC is going to kick on. Okay, it's called heating and cooling degree days. It adds them up for the whole year. Okay, so I'm going to show you some numbers here, and this is basically how much either your heater works for heating degree days or how much your AC works for cooling degree days, assuming you're going to set it at 65.
Okay.
Yes.
Like,
So not so surprising. Look who's at the top of has to run their heater. Yeah, not so
look
surprising.
at Minnesota, they're right up there too.
How about Florida? Let's
Oh,
see.
Miami down there, 149.
What's that?
Florida was 149.
Yeah. Oh, and you said Minnesota in 149. Yeah. So this is how much they need to run the heater. Okay, so the same cities. Now, how much they need to run their AC? 3 degrees. Yeah, and those aren't days, but those are like 3 degrees, like all year long. That deviates.
Right.
I guess it would be lower than 60 or above 65.
Above 65.
Yeah. So yeah, I thought those were
Big
fun.
flip, Minnesota.
You know, but it's funny though because Minnesota, the International Falls, isn't much less on the heating degree days, but a lot more on the cooling degree days. I mean, because
Yeah,
of
that's
the
right.
latitude.
That is.
Probably because where
It's
located,
continental.
too.
Yeah, more temperature swing.
Well, it's probably where it's located, too.
Yeah,
Yeah,
Anchorage is on
it's
the.
inland.
Yeah, that is interesting. Okay, let's see. It says skip the next 2 slides, but I've got them here. They're just pictures, and it's kind of color coded with numbers we looked at. So I'd like to say that this kind of gives you a sense for if you're going to go live somewhere else, where would you want to live, right?
So we're somewhere between 6,000 and 7,000.
Uh-huh. Yep, that looks right. And cooling degree days. How much you need to run your AC. All right. So the last 2 topics we need to talk about are the feels like temperature, okay? And if it's cold like this, the feels like temperature is going to be a wind chill temperature. And we'll kind of look at what today's data looks like. But I'll just put all these up here. I love the concept of wind chill because, oh, by the way, this slide says it, but this feels like of this wind chill, it only works if you're warm-blooded. So the thing is warm-blooded animals like us, basically we ooze a little bit of thermal energy. Like you can feel the heat, right? Okay? And as we walk around, okay, we count on that heat going with us. Okay? It's kind of like our little aura. Okay? And if the wind comes along, basically, there goes that. Okay? And so suddenly, that little aura that you're used to having, the wind has taken it away and it gives you a chilling effect. Okay? So the wind chill temperatures are then like that, okay? So let's go ahead and look at today's, oops, I'm gonna go back. Let's look at today's from the National Weather Service. And the chart is, you can see on the next page for wind chill temperatures. And we'll just see what we got. So the two things, the thing that you've been writing down is not the feels like temperature. You've been writing down the thermometer temperature. But I like this idea of you have to be warm-blooded in order to get that. So like your car, it doesn't care if it's like negative 15 wind chill. It's like, I don't care. Yeah, it cares what the thermometer says. So when this finish is coming up, we'll write down the temperature, which is what the thermometer reads. And then we need wind speed, yeah. We don't really need wind direction. But then we'll look at that chart. Well, no kidding, you're slow.
We've noticed it too.
Here don't like you.
It eventually gets there.
Just sing a little ditty while we
It is coming. I was on the internet earlier. My kids would say I have far too many things open. There it goes.
Yeah, there's a lot of stuff open.
I know. So let's find us 52632. All right. So the thermometer reads 28. Okay, and the wind speed, you see the wind speed 10, good. 10 miles per hour. And then let's go ahead and jot down what they say. They say instead of 28, our wind chill
19.
is 19 degrees Fahrenheit. So that's our feels like temperature. Sometimes the site you're looking at will call it the feels like temperature. So let's take a look at those numbers here then.
Okay, it was like, the wind chill is like negative 10.
Yeah, it can be very
Hit you
cold.
right in the face, like, God.
So along the kind of the Y there, you see wind speed. Along the X, you see temperature. So let's find the temperature first. 28 Fahrenheit. Looks like we got kind of, let's go with 30. That's close enough. And then the wind we said was 10. So here, so where they intersect
21.
would be not bad. Okay, so that's,
28 it probably would be.
yeah. So that's how that works.
Doesn't the dew point or the humidity air affect the temperature change in the wind chill too? The more you increase it?
I've never read that. It could be just I didn't read that. What actually you're getting at is the heat index. So in the summertime, we don't worry about wind, but we worry about humidity. And so there's a different table coming up. Yep. So here's the reason. So you got the reason why we feel chilled if it's blowing wind. Okay. Well, here's the reason why we feel oppressed if it's muggy outside. Muggy means high humidity, right? So yeah.
I hate that we're being colder. You walk outside, it's just like
Yeah.
the air is so
Pe-
thick and
People
moist.
remind me when, I complain about the cold, they're like, oh, just wait for the heat. I'm like,
You
So-
don't get like middle here. It's either really cold or really hot.
Seems like anymore we don't get much of a
Yeah,
spring.
we got the swinging thing going on. But here's how this works, and the thing about us is that if we're working properly, we sweat, and our sweat actually helps to cool us off because it evaporates. Exactly. We talked about the cooling effect of evaporation. So basically, when our sweat evaporates, it is, and we'll talk more about this in chapter 4. It is actually taking some of our energy to go from a liquid to a gas. It's like, okay, I'll take your energy, I'm out of here, and I'm going to cool you off. Okay? But the problem is, if there's already gas particles in the air, okay, gas molecules in the air, it won't evaporate, right?
Is the air just like saturated?
Exactly, because the air's so muggy, and it doesn't evaporate, and we don't cool off. So that's kind of how we have this heat index temperature, as it feels like, because our sweat doesn't evaporate. So, I don't have a good example for this one. We could just pick, because this doesn't apply today. But,
That 136 degrees.
yeah, 136 degrees. Let's pick something, a nice toasty 88. Okay, so that's what our thermometer says. Let's just say, yeah, that you're actually running here in Iowa, 85% humidity. It happens. So what's your feels like temperature? Yeah, exactly. That would be the heat index temperature. But let's say that you're at 88 and you're in Arizona, dry heat.
Dry heat.
Let's say you're at 45% relative humidity.
Feels about the same.
It only feels about 89. Okay, so that's
Just a
kind of,
1 degree jump.
yeah, just 1 degree. But there's where the thermometer, if the air mass is dry, you're going to feel like that. If the air mass is moist, it's going to feel like that. And this color coding, as you know, is where safety enters in. Okay, so the red is very bad. The orange is not good. Okay, and this, you know, you can kind of see where. Yeah. So we'll be talking more about humidity in chapter 4. And that's it. So those questions will be due Wednesday. Remember, if you don't have them to hand in to Mr. Salee, again, I might be here, who knows? But if I'm not, he's agreed to come. And if you don't have them ready to hand in to him, you can slip them under my door. Okay, but they'll be due by the end of the day, 3 p.m. Thursday, or Wednesday. What's that?
Or you can enter them and drop them.